Welcome to Sundar's lecture. This is lecture number 98, and in this lecture we are going to see three-phase power and then power factor. See, we are not going to see any derivations or theory content to know what is the power factor, because we have seen everything in single phase AC circuits. So now what we will do, we will take some problems and we try to learn what is the power and power factor associated with the balanced load. See, whatever we are seeing in this particular lectures, all are balanced load. That is the point you have to perfectly understand, right? Now we will take first problem. This is problem number 1. Phase sequence is ABC in a three-phase circuit, and they have given you, right? ABC is the phase sequence. Considering VAB as a reference. So VAB as a reference means, so they have given you VAB to be the reference, VAB to be reference, and also they have given you ABC sequence, ABC sequence. Those two things they have given, and then find IA, which is mean, what is this one? This is actually a phase current, right? This line current, and the total power PT consumed by the load, given that ZP is equal to 25 at an angle of 60 degree, right? We need to find, they have given you ZP, which is equal to, that means per phase, which is equal to 25 at an angle of 60 degree ohms, which means this value, these values. Right now, what they are asking you to find, they are asking you to find what is the value of IA and real power. Real power, it means we will directly write PT. So total real power consumed, right? These are all the given data. Then what we can do now, see, now maybe here they have given you the values, they have given you the delta connection. What I will do, I try to convert that into star now. What we will do for the star connection? So EZY, that means I am going to change this delta connected impedance to star. Then it will be EZ delta divided by 3. Right? We have seen these kind of equations. Why I am writing this one? I have already derived this particular equation. So it will be 25 divided by 3 at an angle of 60 degree. Right? This is the star connected impedance, equivalent star connected impedance. Why I need to go for star connected impedance? Because if I find what is IA, if I need to find what is IA, then it is very simple in star connected load, because if you want to find what is IA in delta connected load, then you need to find this current and we need to minus those two current to find the value of IA. But in star connected load, IA will be equal to I phase. So if I find what is I phase, then it will be very simple to get what is the value of IA, because both are same in the star connected load. So what I will do now, if I want to find IA, this is in star connected, this is in star connection, try to understand. What is the formula? That is nothing but it is VA divided by EZY. Am I right or wrong? If it is a star connected load, if it is a star connected load, let it be like this. Then if I want to find what is the IA, if you have loads here, I have just drawn the diagram. So what is the value here? It will be VA. Am I right or wrong? And this will be EZY. And what is the formula? It is very simple, right? Because they have given you this value. That means this VAB. That is the what is they have given you VAB? It is like here. Here it is 202 volt, right? They have given you this one. And what is the phase voltage? It is very simple, right? You know already. What is the phase voltage if they have given you line voltage in star connection? It will be 202 divided by root 3. We have seen these kind of things, right? V phase will be is equal to VL by root 3. And if it is ABC sequence, then this will be lag by 30 degree. See, these kind of things, it is very interesting, right? Then divided by, what is the EZY value we found? It is 25 divided by 3 at an angle of 60 degree, right? So now, if you simplify this, what is the value I am getting? If it is IA, that is equal to 116.624 at an angle of, you bring this 62 in numerator, it becomes minus 90 degree, whole divided by the value, it is 8.33, and finally if you simplify this, you will get IA value. You will get IA to be 13.995 at an angle of minus 90 degree, right? So amperes. So this is the value of IA we found. Now what you need to find? You need to find what is the value of PT, that is the total power. Maybe I will go for ST, that means total kVA rating. Total kVA rating, that should be is equal to, this is what we have derived in the previous class too, 3 into VA into IA star, right? Into IA star. Then what is the value? We know everything, right? 3 multiplication of, what is the value of VA? VA, that this is the VA, right? This is VA. This is phase voltages, right? You need to write this value. So 202 divided by root 3 at an angle of minus 30 degree. So this is the value, right? Multiplication of this IA. I am just taking this to be 14 because this is nearly 14, right? So 14 at an angle of minus 90 degree. So finally, if you simplify this value, yes total, I am getting it to be uh, the value, I am getting 2449.12 plus j 4242. Right, that's all. Right, now this is the value I'm just getting for if you simplify this value, then what is the PT here? What is PT? This is the value of PT watts, right? This is 2, we have seen, this is the real power, this is the real power watts, and what is the Q value I'm getting for this particular problem? It is 42 VAR. Right, now that is the question they have asked you to find, right? So this is how you need to get the values of uh, real power and the value of current, line current IA. See, try to understand, they have given you delta connected load here. What we have done here, we have just converted the delta connected load into star connected, equivalent star connected load, and then we have proceeded. Why we have gone particularly to the star connected, that is what I have told you, because to find what is the IA in a star connected load, it is very simple, because IA is equal to I phase. So if it is a delta connected load, you need to find what is the voltage between these 2 points, that is they have given you, and also these two you need to find, and then you need to divide these two values to get the current here, and you need to minus that, and then you have to find what is IA. So it is very not a complicated one. Anyhow, we need to go for 2 or more steps. So what you do, you know this relationship, this is that is why I have told you this relationship is very important, right? So we will go to the next problem now. Right, see, this is the second problem. What they have given you, Z1, the value of Z1, it is 8 plus j2 ohms. Phase sequence is RYB, they have given you. Source voltage is 400 volt. Source voltage is 400 volt, that means the voltage between two lines. You should always get that value. If they have given you like this, then you have to assume that this is the line voltages. And 50 Hz, calculate the real and reactive power drawn from the source. Also find the power factor seen from the source side. And you need to find what is the real and reactive power. So you need to find what is PT, and you need to find what is QT. QT, not exactly P and Q. Maybe I am just writing PT and QT, and you need to find what is the value of pi, power factor angle, right? So now what you do, we will just write what all the data they have given you. So Z1, what is the value of Z1 they have given you? It is 8 plus 2j, or you can just convert this into polar form. What is the value of polar form for this? It is, if you convert this, you will get 8.0 2462 at an angle of minus 14.036 degree ohms. That's all. And you see, what is the formula for S or ST? Maybe I will write it as S. What is the formula for S? S it is equal to 3 into VA into IA, right? These are all phase. If you put phase, then it is 3. Right, if you put line voltages, then it is root 3 VLIL. Right, to understand that one, it is very important. Right, then what is the value of VA? See, we need to find what is the value of VA. See, in delta connected load, what is the value of VA? VA, that means VL, which is equal to V phase. Whatever they have given you, you can directly put that value. You can directly put that value here too, right? So that is very simple, no problem whatsoever. Then what we will do now? We need to find what is the value of IA, right? What is the value of IA? Now IA, that will be is equal to IA, that will be is equal to a VA divided by ZP divided by Z1. Maybe here they have given you Z1, right? So what we can do now? We can go around this. What is the value of VA? VA, that is equal, because phase and voltages of phase and line are equal. So if this value will be 400 at an angle of 0 degree divided by Z1. What is the value of Z1 they have given you? It is 8.2462 at an angle of minus 14.036 degree, right? So if you simplify this, I will get IA to be IA, that is equal to I am getting 48.507 at an angle of minus 14.036 degree amperes, right? Maybe a phase current or anything it may be, right? So what I can write here, so I found what is this value and I know what is this value, so you can easily substitute it now, right? What is the value of S? What is the value of S now? It is 3 multiplication of 400 and multiplication of 48.507 at an angle of minus 14.036 degree. So if you further simplify this, then what you will get, S will be is equal to 56470.59 plus J 14117.060604. So what is this value? This is nothing but PT in watts. What is this value? This is nothing but QT in VAR. That is the two values you need to find. And if you want to find what is the value of power factor angle, so you know, right, this is the diagram. We have seen these kind of things already. Anyhow, I will draw it again. So this is nothing but ST, and whatever here it is QT, and whatever here it is PT, right? So what is the angle? This is the pi angle. So if you write it for tan pi, if you write it for tan pi, that is opposite side by adjacent side, it will be QT by PT, right? It is QT by PT. So if you do so, you are getting two values here, both are here. So if you finally find what is the value of pi, then obviously you have to get it as 14.036. This is the value of pi. Try to understand degree pi. See what is the value, whatever you are getting here, because whatever you are getting in the impedance angle, that will be the power factor angle. That will be the power factor angle. And if you put power factor will be is equal to what? Cos pi. And if you substitute this value, you will get 0.97 lagging, because this is a inductive load. That is why you are getting minus here. So it will be a lagging power factor, right? So that is what they have asked you in the question, power factor angle, and what is the real and reactive power. We have found everything. So we will go to the next problem now. Right. See, this is the next problem. See what they have given you for the circuit. Z is equal to whatever the value of Z. Z is equal to, it is 200 plus J 200 ohms, and Xc is equal to 2650 ohms. What is the value of Xc? It is 2650 ohms. Calculate the power factor with and without capacitor. You have to find both values, with and without capacitor. Right? With and without capacitor means with the capacitor, what is the power factor of this particular circuit, and if you don't have any capacitors, then what is the power factor value. And they have given you the supply voltage to be 400 volt. Supply voltage to be 400 volt, then it is the line voltages, right? So now let us assume that the given question is very simple, right? So they have given you Ez will be is equal to 200 plus J200 ohms, right? And the value of Xc, which is equal to 2650 ohms, and also they have given you the value of VL, that is equal to 400 volt. And you see, what is the power factor? It is very simple, right? I have already told you the power factor angle. What is the angle between these two? The angle tan theta. If you go for tan pi, this is very simple. If you take tan pi here for this one, obviously you will get 1, right? You will get 1. So if you are going for pi, then what is the value of pi? Pi will be is equal to 45 degree, right? Pi will be is equal to 45 degree, and so what is the cos pi value? Then cos pi will be is equal to 0.707. See, just convert this into polar form. Then obviously you will get, or you can do like this too. Anyhow, everything is same, but you will get the cos pi is equal to 707. So power factor, this is without capacitor. Simply, you don't need to do anything. Without capacitor. I have found this value. No need to go very deep into this one, because you know the whatever the power factor angle you are getting here, that is nothing but the power factor. So whatever the angle you are getting in the Ez, that is nothing but the power factor angle. So I have found this one. Now what I will do? This is the first one. Without capacitor we have found, and now with the capacitor, with capacitor, with capacitor, and I need to find first one. See, before this anyhow, I just want to find certain things that, so that it will be easy. See, without capacitor itself, without capacitor, what are all the things I can find further? See, what is IL, which is equal to I phase, because this is, see, you don't see this capacitor is connected, so it is star connected load, it is a star connected balance load, so it will be I phase, that should be is equal to V phase divided by Ez, right? So what is V phase here? So they have given you VL, right? VL. So what is this value? This is 400 divided by root 3, because you need to find what is the V phase in star connected load. This is divided by root 3 and divided by what is this value? This is Ez. What is the magnitude of the Ez? So if you find this magnitude, then it will comes out to be 283. So if you simplify this, I will get, I'm getting it to be 816 ampere. So we have found what is the value of IL. Now if you want to find what is the value of QT, so what is the formula? It is root 3 VL IL sin pi, right? So all the values you have with you, right? So see here, root 3 into 400 multiplication of 0.816 multiplication of sine of 45 degree, right? So 45 degree, and if you simplify this, you will get QT to be 400 VAR. That is the value. And if you are going for PT, it is also simple. Root 3 VL IL, and this is cos pi. So it will be root 3 into 400 multiplication of 0.816 multiplication of cos of 45 degree. So if you simplify this, then obviously you will get PT to be 400 watts. So see one thing, That is this is what you need to get the values, because this real power will not change. If you connect any capacitor, the reactive power is going to change, right? For this particular power factor angle, power factor angle, it is 45 degree, power factor of 0.707. The value of reactive power, it is 400 volt. Then if I add the capacitors, then what will be the reactive power? That is what I need to find. If I add the capacitor, then what is the reactive power value? If I know, I can minus that value to find what is the value of the power factor, right? So let me do that so that you can easily understand. Maybe I will cut it down. So now without, now the second one, with the capacitor. With capacitor. See, up to this, whatever we have found, it is without capacitor. Try to understand. Nothing. We have not connected any capacitors here, and without capacitor, I am getting this is PT, this is QT, right? Now, with the capacitor, what we will do? So, capacitors are connected in capacitor. See, capacitors are connected in what? In delta manner, right? Delta connected manner, right? So, what you can do now? So, if capacitors are connected like that, so capacitor current, current, that means line current. So what will be the line current of the capacitor? So I will write that as ICL will be is equal to root 3 times the phase current, right? What is the phase current? Phase current, which is nothing but it is 400, that is the value of voltage they have given you, 400 volt. That is the line and the phase voltage. In delta connected, it will be same. Try to understand. So it is phase voltage divided by the value of XE. XE, that is the value of XE. What is the value of XE? It is 2650. So 2650. So if you simplify this, what you will get? ICL, that is line current in the capacitor, it will be 0.261 amperes. So now you see, if I want to find what is the QCT, which means what is this one? Reactive power of the capacitance, right, will be is equal to root 3 times VL, and then what will be the ICL, because you see VL, because these 2 points are connected across 2 lines, so VL will be 400, so you don't worry about that. So multiplication of sine of pi C, that is the capacitor angle. So if I do so, what I will get? So root 3 multiplication of 400 multiplication of whatever I have got in ICL, that is 0.261 multiplication of what is sine pi, that is very important. Sine pi of C. See, in capacitor, what is the angle of the current? It will be 90 degree, right? It will be 90 degree. So obviously this value will be 90 degree. So what is sine 90? It will be 1, right? It will be 1. So if I simplify this, see, I need to explain you. That is why I'm doing these kind of things. So QCT, what is the value of QCT I'm getting? It to be 181 VAR. If you simplify this, you'll get the value, right? So what is the thing I need to find now? See, with the capacitor, the capacitor has reactive power of 181 var, right? So this is the var, that is reactive power we have found without capacitor. So what is the value we will get now? What is the total reactive power? That is means you take it as Q dash will be is equal to QT minus QCT. If I minus these two values, so because this reactive power will be cancelled, it will be minus from the total reactive power. So what is the value I will get? So 400 minus 181. That is the total reactive power now with the capacitor in the whole circuit, right? That is the value. So what you will get here, it will be 219 VAR. 219 VAR. See, now what I will do now, so if I want to find what is the tan pi, I have drawn the diagram to already. So So again and again I don't need to draw because you people have already know. So this is the value of S, and what is this value? This is the value of Q, and this is the value of P. So this is pi. So if I go for tan pi, what is the value? It is Q divided by P. So now I will take Q dash, right? What is the value of Q dash? It is 219 divided by what is the value of P? That will not change. Real power will not change. So that is 400, right? So if I do so, I will maybe whatever the value you are getting here, that is nothing but tan pi value. So what I can put here, so pi which is equal to tan inverse of 219 divided by 400. So what is the question they have asked you? They are asking you to find what is the power factor angle. So what is the power factor value? So obviously I can straight away write power factor will be is equal to cos pi, right? So if I do so, cos of tan inverse of 219 divided by 400, straight away I can go, right? So if I do so, the power factor will be is equal to 0.877 lagging. Maybe this value will be lagging because already it is a lagging power factor, right? By capacitor I have made this one. See what is the power factor improvement now? Here without capacitor I am getting some 0.707, and with the capacitor I have got it to be 0.877, right? So is this can we find only by this way? I can also find it in another way. We will find it out. It is a easy procedure to find what is the power factor if capacitors are added in another way, right? See, an alternate way we can go for an alternate to find the same problem what they have given you. So this is the z value and this is the xe value, and you need to find what is the power factor if capacitors are added, right? So now you see we know, right, without capacitor and we don't need to go very further. Without capacitor, because we have already seen this, without capacitor what is the power factor we have found? The power factor will be is equal to 0.707, right? That is the value we have already found. See now what we have done here, this value, this capacitor that is connected in delta has been converted into what? Equivalent star. That is also possible, right? So I will write it down here. So now it is with capacitor, with the capacitor, what you will get? It is very simple. So they have given you Z is equal to 400 plus 400J, right? Maybe 200, right? Make a mistake, right? What is this one? It is 200 plus 200J. I have already written here. So if you just convert this into polar form, you will get 282.84 at an angle of 45 degree ohms. Now the value of what is the value of Z delta ZC, that is capacitor, impedance of the capacitance at delta connection, it is minus JXE, right? Because this value, right? Minus JXE, what is this value? And it will be now 2650 at an angle of minus 90 degree. Maybe the J I have converted that into minus 90 degree. Right now, what is the problem here? What is the value we will get if you are converting this into EZCY? That means you are just going to convert this delta connected impedance into star connected impedance. Then what is the value? It will be obviously EZC delta divided by 3. You know, right? Because this is what we have already seen, and you will get 2650 divided by 3 at an angle of minus 90 degree. So what you will get for ZCY? What is the value? ZCY can be found it to be 883.33 at an angle of minus 90 degree, right? Minus 90 degree ohms, right? Now you see what we have done. This one, we have just converted this delta connected capacitive impedance into a star connected capacitive impedance, right? You see, because since you have the neutral point, it is very crucial point here in this problem. Because of this neutral point, we are going to convert this connection. These two are now connected parallel. These two are now connected parallel. These two are now connected parallel. And finally, what we are going to find? We are going to find what is the value of EZP. See, what is EZP now? EZP, which is equal to what? The value of already there is EZ and the parallel value of EZCY. Now, you see, it is very simple, right? Because of this one, this neutral connection in the star. Now, what we have done, we can easily convert this delta connected capacitive impedance to the star connected capacitive impedance by connecting parallelly uh, with the Z value, right? So now, if I do so, what I will get, EZP will be is equal to EZ parallelly connected EZCY. So EZP will be is equal to, what is EZ value? We know, right? It is given 282.84 at an angle of 45 degree. At an angle of 45 degree, it is parallelly connected to EZCY, that is 883.33 at an angle of minus 90 degree, right? So if you simplify this, you will get EZP which is equal to the value of 350.9 at an angle of 28.686 degree ohms. See, try to understand whatever the angle you are getting here, and that will give you the value of cos pi, the value of power factor, right? So what is now cos pi? What is now cos pi? It is very simple. Cos of 28.8686, and finally I will get power factor to be 0.877 lagging. See, try to understand certain things very clearly. Because why I am saying this one? See, because whatever the angle you are getting in the impedance of a circuit, and that angle will be the power factor angle. That is what I have already told you, right? I have already told you. Now this is the power factor angle. See, without capacitor it is 0.707, and with capacitor it is 0.877, right? See, that is what we have got in the previous problem. See, whatever we have done, so many things here. We have just converted, we have found what is the current and the capacitive react with the capacitor, what is the reactive power, and we have minus the capacitive reactive power with the original reactive power, and find what is the power factor angle. And now you see, it is very simple. Convert this delta connected impedance into an equivalent star connected impedance, that is the capacitive impedance, and these two are now connected in parallel because of the neutral point in star connection. Now what you have done, you just use the formula parallel connected impedance, and we have found what is the value of total impedance, that is ZP, what I have written here, right? So this is how you can also find the value of the power factor if capacitors are connected, right? So if capacitors are connected, then obviously power factor will be improved, right? That is what we have seen in this particular lecture. See, we have started with the problems. This is the first problem, right? So you need to find what is the total power and real power and reactive power. That is what we have found. And in the second problem, also we have taken a delta connected load, and we try to find what is the power factor angle, right? Power factor angle and the total power. And this problem is very important. If a star connected load is connected like this, and the power factor will be 707.707, if I connect the capacitor in this manner, then what will be the power factor improvement? That is the question they have asked you. So we have found that it will be 0.877. And also you see, I have taken an alternate way to find the power factor without going for the current equation, power equation, nothing. With the impedance only, I have found what is the value of capacitive, what is the value of power factor, right? Improvement of power factor. So if you connect the capacitor, then obviously the power factor will be improved. If the power factor angle is lagging already, right? So this is how you need to find. Thank you. We will see in the next class.